All right, guys. Happy Thursday. We're almost at the end of the week. Um, so let's go ahead and go over the lab portion, which of course is going to review some of the theories and topics that we talked about within Chapter 5, which of course Chapter 5 is titled Analyzing Ethernet LAN Switching. All right. So, um, of course, we spoke about the three major functions of a switch, right? Um, that is a key topic for the exam, but also things to remember as a professional, right? It'll help you troubleshoot better, what have you. And the three major functions, right, of the switch is to one, decide when to forward a frame or when to filter not to forward a frame based on a destination MAC address, right? Two is preparing to forward frames by learning the source MAC address of each frame received by a switch. And last but not least, the third major function of the switch is cooperating with all switches to prevent the endless looping of frames by using spanning tree protocol. Okay, we're going to examine all of that today, right? So let's go ahead and jump in, right? So forwarding unknown unicast frames, right? So that was one of the first things that we spoke about, right? After speaking about that logic, right? Um, of course, forwarding unknown unicast frames. By definition, an unknown unicast, I'm sorry, a known unicast. Let's talk about that first. A known unicast, by definition, right? A known unicast frame is a frame that is forward that is known by the switch, meaning that MAC address of the destination, the destination host, is known by the switch, right? It's locked into that MAC address table. It's going to forward it, no problem, and it would not need to go ahead and perform a broadcast message, right, or unknown unicast, right? Let's go ahead and try to do that today, right? So let's boot up this PC, right? Let's go ahead and do that, right? And of course, I'm in EVE-NG. I love this platform. And we're going to go ahead and emulate an environment, right? So PC2, we're going to go ahead and hopefully it's working. There we go. All right, so let's reset the terminal. Let's make this look clean. And let's give it an IP address. 162, type, .1.0. Let's do 50. Let's do 52. All right, 24. And let's do a gateway of 2.168.1.1. There we go. So go ahead and do that. Excellent. All right. And let me. And this is just an emulated PC. You would not do this on every PC. Okay. I'm going to go ahead and give it a 162. Oh my God, I'm giving it a terrible IP address. 192.168.1.1. Okay, well, we'll figure that out. Let me reassign and act like I got some sense. There we go. Let's make sure we give an IP address within RFC 1918. All right, so that's knocked out. All right, and let's use a help command. Let's see how we do the IP. Okay, IP. Oh, there we go. 2.168. 1.1.1. There we go. All right, that's how you do it. Okay. All right, so we got an IP address. We got the gateway set, right? 52. Let's do it again here on PC3. All right, excellent. All right, there we go. All right, so 192.168.1. Give it 53. Keep it simple, right? And then 192.168. And mind you guys, right? In this topology, I don't have 192.168.1.1 configured anywhere, right? I'm just configuring a gateway, right? So you guys see here it says checking for duplicate addresses, right? Typically a Windows PC, Linux PC, a host is going to go ahead and do that. What they're doing is they're going to do a GARP, right? And you guys will learn about ARPs in the future, but it's doing a gratuitous ARP, right? You guys are probably wondering what that is. Gratuitous ARP, right? If you know about ARP, address resolution protocol, in the simplest terms, what it does is it's checking to see, hey, um, where is this IP address at? Who's the owner of this IP address? Can you share with me the MAC address? Right? Again, address resolution protocol. It's asking who owns the IP address at layer 3. Can you share with me the MAC address at layer 2, which of course, why you'll hear within the industry, ARP is a layer 2.5 protocol. Okay? Sits right between layer 3 and layer 2. All right? And gratuitous ARP, if we're asking for a regular ARP, what the IP address is, gratuitous ARP is a host announcing who it is. Hey, this is my IP address and here's my MAC address that is associated with it, right? What does that mean? So if I go ahead, let me go ahead and close this. If I go ahead and open the switch, and let's take a look at the MAC address table, right? And we've learned about, right? We learned about the verification command for, looking at the MAC address table. Let's take a look at that, right? So we have MAC address table entry, right? PC2 that's hanging off of interface gigabit 0/0, and we have PC3 hanging off of gigabit 0/1. Okay, so we know about both of the hosts that are on this network. So if PC2 was going to try to send traffic to PC3, right? Once it reaches switch 1, it'll know where to forward this traffic. This meets the condition of it being forwarding a known unicast frame. Okay, right? Because again, the MAC address table is knows about both MAC addresses for the source and the destination. Okay, all right. So we don't need to ping now. I don't want to go ahead and go through doing a ping. We're good. All right. So let's talk about flooding unknown unicast and broadcast frames. Right. So we have our MAC address, right? And we spoke about forwarding known unicast frames. And we said known is because the MAC address table knows about it, right? But unknown unicast, right? Unknown unicast means the MAC address table doesn't know about it, right? Right? So let's do this, right? Let's go ahead and add a third PC here. Okay, let's do PC4, right? Or PC1. Keep it simple, right? We'll do PC1. Let's give an IP address and everything, right? Smooth everything down, make everything look a bit pretty, right? And the goal here, right? The goal here is not to just add a PC that is within the subnet, is able to communicate, et cetera, right? The goal here is to go ahead and show you what happens whenever the switch doesn't know, right, the destination MAC address of a host, right? So let's go ahead, open this up. right? And I think we were staying with the theme with the last octet being 50, 50 in the name of the in the digit of the PC. So we're going to do IP 192.168. One day I'm going to get used to this keyboard. Hold on, dot 1.51. There we go. And we're going to put it in a slash 24, 192.168.1.1. All right, we're good. And of course, it's doing that gratuitous ARP. If we look at the, of course, we saw it pop up. All right. Of course, we still got two MAC addresses, but as you can see, we see the MAC address table, right? Updated for PC1. Of course, PC2 isn't there anymore, right? Because of course, just like we spoke about, the aging time for a MAC address table entry is 300 seconds, so 5 minutes. So if there isn't any traffic passing, right, from a host, right, what's happening is that timer, that aging timer is already clocking, right? It's already going and spinning and spinning, spinning. If we don't have any response, once it hits the 300 mark, it's going to go ahead and remove that entry from the MAC address table. The thing about the MAC address table, it is content addressable memory, the CAM table, right? And it's the memory can get used up and of course can hit its limit. So that's why the developers went ahead and put in that feature of aging time. So those MAC address table entries don't ever, stick to the MAC address table, right? And fill it up to the point to where the switch can no longer perform its three major functions because the MAC address table is filled up. Okay, so let's go ahead. Let's go ahead and clear. Let's go ahead and do a clear MAC address table, right? And maybe I got to put dynamic. There we go. It's been a while. Okay, so what that command did, that wiped out all the dynamic entries, right? Dynamic being the switch learned by receiving frames, right, and recording the MAC address by source frames coming in, right? Um, it learned those MAC addresses, right? We still have these PCs here, but since we went ahead and cleared the MAC address table, there are no entries so far. Okay, so what we're going to do, we're going to go ahead and go to PC1. We are going to go ahead and ping this address, 192.168.1.1. Okay, all right. So 192.168.1.1 is not reachable, right? Let's go ahead. We see an entry. We see an entry for RPC, right? Because again, one of its major functions, it's going to go ahead and learn MAC addresses by looking at the source address, right, of a frame, right? So we've learned that. Let's go ahead, right? But we didn't learn the MAC addresses of PC2 and PC3 because again, the source wasn't their PC. Okay. If I go ahead, let's say I go ahead and ping 52, what happens, right? Of course, from a layer 3 standpoint, I'm getting responses. What happens on the switch, right? Right? Okay, we have an entry, right, for PC2, but how did it respond if the switch only learns MAC addresses by the source address of a frame? Okay, let's see why, right? So let's go ahead. Let's do a packet capture. We're going to do a packet capture on gigabit 0/2, right? We're going to go ahead and pop that up. And I just want to see how that traffic looks. Okay. Let's do a refresh. see what's going on. Uh-oh. There we go. All right. So now let's try to do this again. Boom. And let's do the 0/2. See if that pops up. There we go. Okay, so now we are capturing traffic off of the switches interface, gigabit 0/2, that is hanging off that PC1's hangs off of, right? We're sending that traffic from, right, PC1 to get to PC2. So dot 51 to get to dot 52. Okay, let's see if this works, if this pops up. Okay, maybe it'll take a minute, maybe it won't. Okay, nothing popped up. Let's try again. Let's go ahead. Ping. Oops. Start this ping again. And let's try to do another capture. Just to pop up. Sometimes with EVNGs, things get a little bit buggy. Ah, there we go. Yeah. Let's, maybe that feature is not working. Let's see what happens. Okay, let's do this. Okay, let's log back in. Maybe we just need to log back in because it got buggy. All right. Let's see if this works. There we go. See, I blame DeMarco. It was all his fault, right?
Hey
So
Dave,
let's,
quick question. I know this off topic.
yeah.
Is the EVE free or do you gotta
Um,
pay?
the community version is free, right?
Got
The community version is free. I don't recommend the community version, but you can make do what it do with the community version. So don't get it
got
twisted.
got you.
It's just whenever you're trying to turn on and turn off host, it is you have to if you're trying. I'm sorry, if you're trying to connect hosts, right?
Uh
It's you have to turn off the host first, turn off the PC, and then connect it, then cut it back on. Which again, to me, coming from Packet Tracer, that's too much damn work. I don't want to cut the PC on and off. That's
got
too
you.
much. You know what I mean?
Got you.
Um, so I would just go ahead and pay that money to have that license for a year. If I know I'm going to lab, I'm going to pay for that license for a year and go from there.
Got you.
Yeah,
Appreciate it.
no problem. All right, so we're doing that packet capture, right? We finally got it to work, right? Probably time to upgrade my PC hardware, but we finally got it. We're doing a capture off that interface. Let's go ahead and do a ping, okay? Because we're trying to understand how did the switch learn the MAC address of PC2 if it only learns MAC addresses based on the source MAC address, right? Well, if we go ahead and we stop right here, right, we go into Wireshark, all right, we can actually see, what can we see here? We see within the ICMP requests and replies, or AKA the pings, right, the initially PC1 is the source, right? And PC2 is a destination. 192.168.1.52 is the destination. But when it comes to the reply, that is an entirely separate packet, which means PC2 becomes the source at that point. Okay? So this is how, of course, the switch learned about PC2, right? PC2's MAC address. And now it knows about that MAC address, right? Okay, let's do another packet capture. Let's do a packet capture off of PC3, right? That is gigabit 0/1. I know I'm an old man, so I gotta double check like 5 times, right? I blame Donovan and Mykevia for making me an old man during the Fortinet studies. Blame you guys. It's all your fault. Um, but let's go ahead and do a packet capture, right? Because the thing that we want to prove here is what happens for unknown unicast broadcasts, right? Unknown unicast frames and broadcast frames, right? So let's go ahead, see if we can go ahead and get this to cut on. Let's give it a minute. There we go. There we go. And just a quick nugget, whenever you're working with EVNG, whenever you're doing like using a feature like, trying to capture packets or what have you, you can go ahead and outsource it, which is totally fine. But of course, I like to just keep it within the app. It's a little bit easier, right? So that's why you see that pop up for me. But you always want to wait till I'm sure you guys peep until it pops up before you start capturing packets, right? Or moving it to an outside tab, right? So we're capturing now off of gigabit 0/1, right? We have no traffic going there from a layer 3 standpoint. What happens when we do this? You guys see that? Let's do it again. Maybe you didn't see it. Let's do it a third time. Maybe you guys didn't see it again, right? So what is happening here, right? Let's go ahead and filter our traffic so we can take a look at it. So we're in Wireshark and we see this message, and the destination is all Fs from a layer 2 standpoint, right? If you guys remember when we were speaking about in the chapter, all Fs represent broadcast frames. Once a switch gets a frame where the destination is all Fs, okay, the switch will then in turn deliver a copy of the frame out of all the ports within the switch, except for the port it received the frame on, right? This is the process of flooding a unknown unicast frame. Because the unicast being, I don't know where 192.168.1.1 is. Okay? I don't know where this sits. Okay? So I need to go ahead and send out a broadcast, right, via ARP to find out where does this sit. And don't be too focused on the ARP protocol. This is just focused on, from a layer 2 standpoint, what it's doing with the unknown unicast. Once the switch doesn't know about that MAC address, it's going to say, hey, I need to figure this out. So I'm going to go ahead and forward this out of all frames, right? And as you can see, this MAC address, all right, this IP address doesn't live anywhere. It's not PC's 3 MAC address. So of course it is going to be flooded. Okay. All right. So we were able to prove that. Okay. So we got that in play. Let's talk about, you know, let's talk about spanning tree. What happens if we go ahead and add another switch, right? Because spanning tree job is to, um, you know, provide loop prevention with redundant links, right? And there's dedicated chapters, right? Of course, within part three, right? So chapter 9, right? Chapter 9 really digs into it. Chapter 8 goes into, VLANs, but chapter 9 really gets in the nitty gritty, right? Um, but let's see how spanning tree or STP, right? Let's see how it does its job, right? So we got switch to booted, right? Let's give it some time to boot up. Still getting, it's getting everything settled, squared away. All right, let's see. Just to be fair, let's stop it. And I'm gonna go ahead and restart it. There we go. Okay, there we go. All right, all right, all right. So the switch is booting up, right? And like I said, the third primary function of a switch is loop prevention, right? Um, and it's implemented using spanning tree protocol, right? Without spanning tree, any flooded frames, right? By definition, any flooded frames would loop for an indefinite period of time, right? In LAN networks, right? With physically redundant links. Okay. So we get this switch booted up, all good to go. We'll give it a name, right? Name is not really important, but let's say out of the box, we haven't changed anything. We haven't changed any spanning tree values and what have you, right? If we take a look at this, while it loads up all of its interfaces, there we go. It's almost done. Any day now. There we go. All right, so we're good to go. Let's go ahead and give it a name. All right, excellent. We gave it a name. Now let's take a look at switch one, right? We saw the verification command for spanning tree, right? Show spanning tree summary, right? Whoops. Show spanning tree summary. It tells us what ports it may be blocking, but will give us a better view. Show spanning tree. Oh man, can't believe it's been a while. One. There we go. And let's make it pretty. Let's run this command again. There we go. All right, that gives us a lot of stuff, right? So we have all the ports, right? And let's talk about, we'll do a quick Easter egg on all these, right? It shows us all the interfaces. It shows us a lot of things in regarding to spanning tree, which we'll talk about later. I won't jump in now. It tells us the interfaces, right? All the interfaces that are within this specific VLAN. It tells us the role of the interface and the status. Status meaning what the interface is actually doing, right? FWD stands for forwarding. So meaning it is passing traffic for all of the interfaces. Let's go ahead and connect this to the other switch. Okay. So now we have a connection to the other switch. Let's see what happens here. gigabit 0/3, right? Still forwarding, right? Let's take a look at switch 2, right? Of course, we get a bit of syslog messages that are letting us know gigabit 0/0 is changed to a state of up from a layer 1 standpoint, and it's telling us to change to a state of up to a layer 2 standpoint, right? So let's run that same command. Show spanning tree VLAN 1, right? So gigabit 0/0 forwarding. But the role has changed. You guys are going to learn about different roles in the future, right? It is assigned as the root, right? This is telling this switch, right? Switch 1 is telling switch 2, which of course switch 2 is telling us by us entering the verification command that, hey, this is your root port, right? This is where you send all traffic upstream. Everything has to go through your root switch. So this is your root port. If all else fails, we are not, we're still going to do our primary function, right? Our third primary function of the switch, right? Which is loop prevention using STP, right? And we'll block any ports besides this one if you have redundant links. Let's test that out. So let's go ahead and do a secondary connection, a redundant link, right? So now we have redundant links. Now we have gigabit 0/1 off of switch 2 connecting to gigabit 1/0 in switch 1. Let's see what happens, right? First, let's check switch 1. Oops, maybe I can type the command properly, right? Let's see what happened to gigabit 1/0. Nothing. All good, right? We're still forwarding. Gigabit 0/3, we're still forwarding. Nothing has changed, all right? Let's check switch 2. Of course, we got our syslog messages, right? Layer 1 and layer 2 has come up for gigabit 0/1. Let's see what happens. Oh, we got something here, right? So gigabit 0/1, the role has changed, right? ALTN stands for alternate, right? And you'll learn about that role in the future, okay? But the status is set to blocking, okay? So what does that mean, right? Let's pull up my pencil. What this means, change it to green, I'm forwarding traffic out of here. I'm forwarding traffic out of here. I'm forwarding traffic out of here. And I am blocking traffic right here. So what this does is saying, if I have a host, right? Let's say dot 50, what, 54. I'm trying to ping somebody that's hanging off of switch 1, right? We'll say PC1. That traffic only has one way of flow, right? It only has one way to flow, which of course is through the root port. It doesn't have multiple ways to flow, right? Because if we didn't have that spanning tree feature there, right? Let's see what would happen, right? Let's say, let's go ahead and get this. Can I get this eraser? There we go. All right. I know how to do things. All right. There we go. So if I'm forwarding off of both ports, let's just make this diagram, right? I'm forwarding, right? I'm sending that traffic through both ports, right? Copies of that frame is getting sent off of both ports. Now it's going to be sent. Let's say the switch knows about it, so it's known unicast. It's going to forward a known unicast frame. PC1 is going to respond back, and it's going to say, hey, I'm going to send it here. 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 It never reaches here. It is continuing to loop because there is not one way of traffic flow within this, right? The thing with spanning tree, right? Whenever you're building your topologies, it can be with 2 switches, it can be with 3, it can be with it can be with not 1 or 2, right? For these redundant links, right? 1 or 3, one, yeah, 2 or 3. I apologize, but with 2 or 3, it needs to have spanning tree in there so you have one way of traffic flow. Okay, that's what the building the tree is about, right? You need to have that flow, right? That one way of traffic flow. If there isn't one way of traffic flow and there's multiple paths on those redundant links, you will have a broadcast storm. Your CPU will go up on your switches. Your switches will no longer be able to operate. Okay. You can do this within a physical lab. You can actually emulate this. I push you guys to emulate this within a physical lab. Soft, virtual lab, you can't really do it. This is why I push for physical equipment, but you can do it. You can actually turn off spanning tree and see the effects of not having spanning tree enabled. You can go ahead and forward, start to do a ping between 2 hosts and sees what happened, right? So let's go ahead and clear all my drawings. End it right here. There we go. All right. So hopefully that made sense, guys. Um, sorry, my lab time's out if I don't interact with it. So that was spanning tree, right? And of course, we spoke about, and of course, he'll sign me in a little bit. We spoke about the layer 2 logic, right? What happens using using this layer 2 logic, using the following the rules of the 3 major functions of a switch, right? Step 1, switches forward frames based on the destination MAC address, right? Step 2, switches learn MAC address table entries based on the source MAC address. And of course, step 3, switches use STP to prevent loops by causing some interfaces to block what you guys have seen, meaning they do not send or receive frames. Okay? All right. So, and again, chapter 9, we'll talk about some of those your spanning tree concepts. Okay. So, by default, a couple of things we also proved, right? And I'll go ahead and pull this up right here, right? So by default, there are some settings that are instilled within a Cisco switch. I'm going to make sure I said that. That makes it, ready for plug and play, right? No configuration needed, right? All the interfaces, and we'll be able to prove this with some verification commands. All the interfaces are enabled by default. Okay. All the interfaces are enabled by default, and they're ready to start working once a cable is connected, right? Let's do show interface status. Do we have that command? Should. Well, it's been a minute. Yeah, there we go. Okay, we got interface status. There we go. All right, cool. So what does this tell us, right? We don't have configured a port that is administratively shut down. Let's see what that looks like, right? If we have that configured. Let's go ahead and go to gigabit interface 1/3, and let's administratively shut it down. Okay. Let's run that command again. Okay. So you see the difference, right? So if we had an interface that was shut down, that status would be, of course, different than connected or not connected. It's disabled. Okay. So this proves, of course, one of the default settings out the box is that all ports are ready to go. You don't have to enable it. it's ready to go, right? So another thing, right? And let's go ahead, we can reverse that. All right, there we go. We do a no share just to fix that, right? Right. So we're good to go. Boom. We're good to go. All right. So that's out of the box, right? All interfaces are assigned to VLAN 1. How can we check that, right? We could do a show VLAN brief, right? And what this command does, it shows us the VLAN, the name of the VLAN, the status of the VLAN, because it's very important, right? It shows us if it's going to go, if that virtual local area network is working and up and running from a layer 1 and layer 2 standpoint. VLANs operate at layer 2, so it is up and running. And the ports, which verify layer 1, that are associated with it, right? So we have all of our interfaces, gigabit 0, gigabit 1, gigabit 2, gigabit 3, gigabit 1/0, 1/1, 1/2, 1/3, all the interfaces that we see here, right? They are in VLAN 1 by default without configuration. All the interfaces are assigned to VLAN 1, and we're able to prove that, right? Right? Another setting, right? That's by default, right? 10/100/1000 megabits per second interfaces use auto negotiation by default. We can see here without configuration, duplex is set to auto, which or that's what the A is stand for, and then negotiated to full, right? And of course, it auto negotiates the speed. So that's verified, right? By default, of course, the switch, the MAC learning, forwarding, flooding logic, all works by default. At the beginning of this lab, we were able to prove that, okay? And of course, spanning tree is enabled by default. We were able to prove that just seconds ago, just minutes ago, that we didn't configure spanning tree, but it was performing its functions once we added another switch within the mix. Okay, right? We was able to demonstrate MAC learning, how it works. We spoke about the switches interfaces. We were able to find entries in the MAC address table, right? I also showed you guys, right, on how to manage the MAC address table, right? How to go ahead and clear a MAC address table entry. But I don't think I showed you guys how to take a look at the aging time. Let's take a look at that, right? Let's do a show MAC address table aging time, right? So that's where you can actually see your aging time, right? You just put in show MAC address table aging time. It'll show you it's at 300 seconds, right? If we ever wanted to use it, we would have to change it globally, right? We would go ahead and we would go and we can actually set it by VLAN, okay? So we can go to maybe VLAN 1 or VLAN 2 and set it to whatever decimal number that we would like to set it to. Okay. All right. We spoke about the MAC address table with multiple switches. We spoke about that, how that works. And that covers everything that we've talked about within chapter 5. Okay. Let me go ahead and pull over my book. Right. So, guys, of course, now that we're done with chapter 5, this is a reminder. Go over, and these things are critical. Go over the chapter review, right? Go over, some of the, review elements that they have here. Review key topics, review key terms, answer, do I know this already questions, right? Do the labs, review the command tables. And of course, if you bought the book that I bought, the Official Cert Guide Library, all of that comes with it, okay? Watch the video on the website, right? Review the key topics, review all the key topics that they have here, right? And again, Cisco is trying to tell you whenever they put this out is that, hey, this is going to be on the exam. Please review it. Please understand it, right? Do the lab, right? The SimLite software is a version of Person's full simulator, a learning product with a subset of its lab, yada, yada, yada. Now, SimLite software is amazing. Also, I push you guys, right? Because as engineers, right, as scientists, there's not, there's multiple resources that you can use and go to, right, to learn some of these concepts. You guys can have a Udemy course. You guys can go to YouTube. And some people will build labs. You guys are going to be engineers in the future. Download Packet Tracer and start to, emulate your labs after them to try to get the concept, right? I told you guys about Near Anderson, his Udemy course. It is amazing. I use that for my CCNA and the CCNP. Helps out tons. David Bombal is great as well. Um, so just keep that in mind, right? Always use multiple resources to get the point across. Because while you guys don't know, right? A lot of the things that I learned within routing and switching was not just from Cisco. I've learned it through Aruba. I've learned it through Palo Alto. I've learned it through CompTIA, Microsoft, a lot of these things. So there's more than one resource that you can go ahead and use. Okay. Of course, it goes over key terms that you should know. This means you are going to see these terms on the exam. Some command references. You will need to know these command references for the exam. Understand that? Okay. And that's it. Any questions?
No, it was more understandable.
Okay.
You basically covered everything. Just one thing.
Yes, sir.
The alternate port. I mean, on the port alternate. So that port that was blocking, but it had alternate. So if a link go down, that port will pick it up, right?
Mm, absolutely. That is the job of it. And we'll go over it more in the future, because that's when the lab starts getting fun. Um, and we actually won't be using a lab, right? Whenever we jump in the spanning tree, my goal for you guys, a quick little Easter egg, is I don't want you guys to be solely dependent on what you can configure, what you can verify. I need you guys to know this in your mind.
Gosh.
Okay. So um, I won't spoil it now, but you won't see a lot of labs from me. We would actually be using a pen and a piece of paper or a virtual whiteboard to learn spanning tree. Okay.
Gosh.
So get ready to have fun. All right. You guys have a great night. Wait, before I leave, any other questions? My Kiwi, you're good to go?
Oh, no, I'm good. This is
Okay.
good. Yeah, this
Okay.
is good.
All right, guys. You have a good night.
All
Thank
right.